Good afternoon, everybody. So welcome to the first community meeting. Actually, it's not the first, but it's like a new beginning because it was done a time ago and then major changes undergo into the Liqo project and community and so on. So we stopped it for a while, but now it's definitely time to restart here. So, welcome to everybody. I don't know if I have to say good afternoon, good morning, or good evening, or whatever. Many people here. So let's briefly introduce the agenda for today. Sorry. So a few words on the community, how we structure the community. Everything can be changed, of course, but this is the way we structure it right now. Then an overview of the Liqo 1.0 that was a major milestone for us, plus a live demo. Then we can introduce a new feature proposal that was actually proposed by a person from Polito, so the University of Torino. And then let's give some floor to ideas, comments to the entire community. So the first part, understanding the Liqo community, will be presented by me. We decided to create a new repository for the community, just in order not to pollute the main Liqo repository with the source code. The new repository is the Liqo Community repository. Sorry, I'm making some mistakes with the pen. Okay, so the new Liqo Community repository where you can find the minutes of the meeting, the slides, possible demos, and so on. So something that is related to our activity as a community. How do we meet, or how often do we meet? We decide to meet, let's say, not strictly periodically, because it depends on whether we have to discuss, we have something to discuss or not. So we decided that the meeting should be called in a proper Slack channel. So we created a Slack channel dedicated to this in our workspace. You can propose a new idea, you can propose the topic and the agenda for the new meeting, and then we schedule a new meeting in the next coming weeks. If not, our proposal will to meet anyway every, let's say, 4-6 weeks here, in order to possibly discuss something and meet in general the community in terms of use cases, ask to the questions, and so on. So just to be prepared, the idea of the meeting should be discussed on the community. We would like to be more open. More open means actually the more we can actually, because we would like to have different people from different companies working and collaborating on this project. So we would like to be absolutely open. So the community meeting Slack channel is actually dedicated to that. Also, the announcement of new meetings and the agenda of the upcoming meeting will be broadcasted there. Anyway, meetings are being recorded, so they will be released publicly. So not just the documentation, but also the recording of the meeting. If you are interested in generally how the community is structured, not the community meeting, but the general community, you can find here the link where we structure the community. So who are the maintainers, who are the different roles in the community, and also the rules to be part, have let's say, a structured part on the community. So if you want to become the new maintainer, replacing like my position, because I have so many things to do, But anyway, you can find all the rules over there. So that's all for my part. We will be very happy if you go to the community channel and the community documentation. If you can make a request, comments, and we will be very happy to update and accept suggestions. So let's give the floor now to Alessandro and Francesco
Yes.
for the Liqo 1.0.
Yes, I still use the screen sharing. So let me know if you are seeing my screen.
Yeah.
Okay. So let's we go with the second step of this meeting. That is an overview over the new Liqo 1.0 release that I think is the most important things happened to Liqo in the last month. The main reason of this new version is to underline the maturity and the robustness of the Liqo project that is now suitable for production environments. We saw that many people are using it also in production environment. Its vision and the use cases are validated, and now with this new release, also the core modules and the APIs are now mature and stable. This change of version is reflecting the readiness and the stability of Liqo, and starting from now we will we'll try to avoid critical and breaking changes between version, and we'll support upgrading between them. The main work we did was to make it more debuggable and more configurable. In particular, we divided the core functionality of Liqo in three main modules. Making them independent and configurable, each one separately. Each module has its own customer resources that enable seamless integration with any workflow that are in your components. So, Francesco.
Okay. Hi to everybody. Now we're going to talk about the Liqo modules with a quick overview about the news that the new Liqo version is bringing inside every Liqo module. So the first module is the network module, which allows to achieve a full pod-to-pod connectivity between each cluster in the Liqo Federation. So the news with this new version is a new design, a new network design of our network that now unlock the support for different network technologies and brings a better throughput and scalability in Liqo. Then there is the authentication module, which is responsible for the creation of the Kubernetes users that are used by every Liqo components when a Liqo components need to talk, to communicate with another remote cluster of the federation. So now the authentication process has been simplified a lot. Now it's declarative, completely declarative, and the permissions required by the users have been minimized. And then finally, there is the core module of Liqo, which is the offloading module, the module that uses the famous virtual kubelet, which allow to manage the life cycle of the virtual nodes. And here the major news are the possibility to create multiple virtual nodes for the remote clusters, of course. And we also introduced a new customizable management of the resources exposed by each virtual node. So, thank you.
Hi everybody. Hi everybody. We just want to expand this part about the declarative API by saying that Liqo has been completely redesigned to be fully declarative through our CRD's API. This means that now you can install Liqo, configure it, and peer cluster just by applying our custom resources in the cluster without necessarily relying on the Liqo CTL. This means that now Liqo, compared to the old one, seamlessly support the DevOps workflow, enabling various automation use cases. For example, you can enable GitOps approach. So you have your favorite GitOps tool, like Argo CD and Flux, and you can just use it straight away with Liqo. You can have continuous delivery, or even integrating Liqo with third-party services that use our API. That's it. Now I will leave the presentation to Alessandro that will show us a live demo of the new Liqo.
Yes. This demo is a general overview of what Liqo is doing to show you that it can be used in the same way that was usable the old Liqo. So the demo is very similar to the Hello World, the quick start of Liqo. We will see both the generic workflow that is similar to the old one, and we see also how to do the same peer, the same structure, the same architecture using the module specific commands. So here we have two clusters, one on the left and one on the right. And we already have Liqo 0.1 installed on that. So we can see the version we have Liqo 1.0 installed on both of them. So we can use as usual Liqo CTL to peer both of them. What is required is the couple of kubeconfig in order to establish the connection between of them. So one of them is already exported. So the one of cluster one config is already exported. Then to the command of peer, we can pass the second kubeconfig, and we also specify to the command that we want a node port service because I don't have load balancer services installed on this environment, but obviously load balancer is supported and is the default choice. So we can run this command. We can see that Liqo is doing a lot of things. They're setting the networking and still setting the networking. So we can see that new pods are being created on the provider cluster. So the one that will provide the resources. We are creating a gateway. We can see that when the gateway is up and running on the provider cluster, another gateway is created on the client side, so the consumer side. Now is waiting that the connection is established between of them. Okay, and is continuing with the other modules. So it's creating the authentication and creating the offloading part. So we can see that also a new pod is up. This pod is the one that is running our Liqo cube. So as usual, we can see that sorry, not yet. Now a new node is appeared in our cluster, so we can, as usual, use it to schedule pods and to run our application to the remote cluster. Now we will see how to completely destroy this peering and how to redo the same things using the single module commands. So to completely remove this peering, we have the Liqo CTL command unpeer that we can use with again our couple of configs. We can run it and see that everything we created before is disappearing. Okay, now I clear the screen and we can do the same thing using specific command operations. So now we can start both using authentication or networking modules are completely independent. We can choose the order, but we start with the networking one. So to establish the networking module, we have a generic command. You can do it with CRDs. You can apply CRDs directly on to the API server of clusters, but we also have a command to simplify this workflow. This command is licoctl network connector. Again, we are passing the same arguments it was passing to the generic command. Here we have more specific commands, so we can customize other things in this setup. But for now, we are recreating exactly the same scenario. So the connect will run again the same steps that licoctl was running for the generic command. We are seeing that the gateway is up again. We are waiting for the service to be ready. Okay, the service is okay, and the connection is established. As we can see now, we only have the connection established between these two clusters. If we want to check if the connection is okay, we can, for instance, get the connection resources. That is our custom resource that we created that simply tells in each cluster if the period one are ready to be consumed through the network. As we can see, at the moment, we don't have nodes because we didn't enable the offloading mode. We can go with the second module, that is the authentication, and we can licoctl authenticate. Again, we have to pass the couple of kubeconfigs. We can apply this command. You can see that Liqo is again doing some things in both clusters. We can see now that we have identities on this cluster. The identity is mapping a user to the remote cluster with minimal permission to operate on the tenant namespace and with the Liqo control plane resources. Now the consumer cluster is able to create the offloading resources to the provider one in order to ask for resources. To do it, we can, for instance, use licoctl create resource slice. We are passing the remote cluster ID because now Liqo know how to call the remote cluster as a user to apply resources to this cluster. We can use the name we want for this resource slice, for example, pool 1. We can use licoctl to directly apply these resources to the cluster, or if you want, you can also use the YAML resource. If you do that, you can see that is a standard Kubernetes resource. We define a custom resource definition, that is a resource slice with our flags inside. We can run the command to directly apply it. The resource slice is created. We can see that when the resource slice is created and the remote cluster accepted it, we have the virtual kubelet pod that is running exactly as before, and we can see that the node is not yet up. Okay, just a moment. Okay, now is up and running. Okay, so we are exactly at the same configuration that we had before. We have recreated exactly the same configuration. We can now demonstrate that everything is working. So we can create namespace Liqo demo. We can create a deployment in this namespace. We can check that the pod, sorry, I forgot to licoctl offload namespace Liqo demo. with enforced name mapping strategy. That is exactly the same command of the old Liqo resources. Again, we can YAML it to have the resource to apply, or we can run LiqoCTL directly to create this resource. Now I think I have to delete the pod because it's actually running locally, because we forgot to flood the namespace before. Okay, now that I deleted it, the Kubernetes scheduler is recreating the pod, and we can see that it's running on pool 1 node that is again offloaded to the remote cluster. We can see it running in here in the remote cluster. We can expose this deployment. We can get the service that we are using. We can, for instance, run in a default namespace an Nginx pod in order to contact our offloaded pod. We can run bash in this container. We can curl for the direct pod IP, and we can see that it's working. We can curl for the service IP, and we can see that it's working as expected. So everything, the user experience is exactly the one that you had with the old version of Liqo, but we have more flexibility and more configurability of your infrastructure. And I think it's all for the demo. I think we can go on with the next step of the presentation, and I leave the space to Santo that will show us his work.
Yeah. Thanks and good evening to everyone. Today I will show a possible, not solution, but a possible implementation of a centralized management of the Liqo network creation. That is a first step for the optimizing of the shortcut between two leaf clusters. So I will show you a topology over the one I will explain what we implemented. And it's a basic topology with a main cluster that is cluster Europe, that is in peering with Rome and cluster Milan. These are the configuration of the network.
Sorry,
yes?
I'm not seeing your screen.
Okay. Sorry. I'm not sharing the screen. Okay, are you seeing it now? Okay, perfect.
Yeah, thank you.
So in this topology, we have the main cluster, that is the cluster Europe, in peering with Rome and Milan. And these are the configuration of the network. So all Europe can contact Rome and Milan, and vice versa. So the main idea, what is the main idea? Is that we want to connect directly, in a direct way, the cluster Rome with the cluster Milan, in order to relax the overhead of traffic that is routed through the main cluster. Because at this moment, as you know, if a pod in cluster Rome want to communicate with a pod in the cluster Milan, it should be routed through the external CIDR, pass through the main cluster, and then it will be routed to Milan. So the idea is to create this direct connection, and it is possible using the Liqo network command that was described before. This command it is executed in one of the two clusters. So, for example, in the cluster Rome, and using Liqo network connect, specifying the remote kube config of the second cluster, it will create a direct network. So our topology will become in this way. We will have a third connection that we can call it a shortcut between Rome and Milan, with the same with the relative network configuration. What are the problems, the main drawbacks of this configuration? is that the main cluster has no knowledge, is not aware of this connection because it was created in one of the leaf clusters. And as I mentioned before, the command should be executed in one of the leaf cluster, and the shortcut is connection is decentralized, so it's not managed by the main cluster. What is the proposed solution? Is to create a CR, a custom resource, a new custom resource with a relative operator that in the main cluster that will describe this connection. In this way, the main cluster will be aware of the existence of this connection, and the route can be configured accordingly with this new CR. So in this case, for example, in fact, this is a first step for the final goal of the original final goal of my thesis, that was optimizing the shortcut. What happens at this moment? That if we expose a deployment, so it is visible for with a service, the are created some endpoint slices, and the endpoint slices that that ROM will see are routed through Europe. So if Europe has know that there is a shortcut, in a next implementation, it will be possible to specify the direct connection, so avoiding to pass through the main cluster and relaxing its traffic. So the proposal is to create a new Liqo command that will create this new CR. This CR will contain all the metadata and the information about this connection, and an operator will be triggered at the creation and deletion of this CR, and will execute the Liqo network connect command accordingly. If you want, there is also a short demo where I can show how it should work, how I thought it should work. And it, un secondo. Okay, so I already created the controller, a sort of controller that is already working, and in the cluster ROM I can show you that at the moment there is just here. There is just the connection with Europe Cloud. So if I create the CR, so to apply test connection YAM. So the CR is created, and now we can look again at the Liqo info peer command. And as you can see, the direct connection directed to Milan is in the creating phase. So if you look again, it's not ready. We can look at the gateway. The gateway to Milan it's already created. This command was executed inside the main cluster, so on the cluster Europe. Here we are in Rome, so in one of the leaf cluster, and we can see that here. Okay, the connection is working. So if now I access one of the pods, so the offloaded pods, in this case Liqo, and we try to contact directly the pod on Milan without passing through Europe Cloud, so 10.63.0.12, it is they are communicating in a direct way.
Okay, so you need to have the direct pod EP in order to be able to do.
Yeah, in this case, yeah, actually yes. But in our next step, we want to propose to update the generation of the endpoint slices. So if Europe know about this direct connection, we can propagate not the IP, the remote IP that pass through the external side of Europe Cloud, but we can pass directly the 10.63.0, the address of Milan, the direct address, and avoiding to pass through the main cluster.
Thank you.
Thank you.
Just a few words about your work. I think is something that Liqo really need a way to allow a direct connection between remote clusters. So thank you for your job and good job, of course. Just a few words about your proposal about a new command inside LiqoCTL. I understand that it can be really useful for users to have a new command to automatize all these mechanisms. But I think that for a first period, we can think about creating a separate CLI or a separate script just because we need to check how the community react to this new feature. So I think that for a first time, it's a good idea to keep your project, okay, as a separate side project. And then if the community decide to adopt it, and if a lot of people want this feature inside the core of Liqo, we can think about merging the two projects. But for the moment, thank you for your work.
So only one small thing. Correct me if I'm wrong, but you didn't change anything in the core of Liqo. Is only control plane on top of Liqo.
Yeah, it was
I
just
just used some function that was already disponible by Liqo. So like the actually the operator just use the run connect function of Liqo and use that without any modification.
yeah. No, it was just a comment about the part of
No.
in LiqoCTL.
Yes,
Yeah.
no. It was to make the presentation complete. Obviously, the command was just an idea for future implementation, not something that actually should be implemented.
Yeah. Okay.
So I think that we fear that we didn't have enough time to present everything. So we were running a lot, and now we have a lot of time for questions. So the meeting, is our first community meeting. So we have to set up everything perfectly. So please excuse us if we are not perfect today. But the three topics that we presented today were the rules that we decided for the time being for the community, then a brief overview of Liqo 1.0 and the main features, and then we started with Santo, the first feature proposal for Liqo. In order to actually open the community and discuss new features across all the potential users and not within a restricted group of users. By the way, Santo, it would be nice when you upload the slides if you link also the GitHub issue, the feature proposal that you created, where you have a little bit more details, and also the code that you made, so that the people can inspect and check and make the comments on the code as well. So community, Liqo 1.0, and then Santo, and then of course other features. So we can open up now the comments to question and from the entire community. If any, but I hope.
Well, I don't know if this is the place to make this type of question, but we are using Liqo in we are trying to use Liqo to make lots of things. So we have encountered some type of problems. So one thing that we have wondered of is that is possible to unpeer a Liqo connection if the provider cluster has gone away, so exploded, or something has been done for this, because or maybe the network connection has gone away, or he has been dismissed or something like this. So we have to unpeer before something happens, but we don't know if something happens of catastrophic. So we can plan for planning this mission, but not for unplanned or not, or something that is not planned.
Yeah, sure. I can try to answer this. So first of all, I think we can divide into kind of a missing cluster. So we have a temporary issue. So we can see that the virtual node, the connection is no more available. So following the standard Kubernetes logic, Liqo will move away the pods scheduled on these clusters to others. If the question is about cluster that we will never see in the future, so you destroyed the cluster and this will be never available again. We improved the behavior we had with the 0.x versions of Liqo. So now is easier to clean up the consumer cluster if the provider is gone, because we reduced the number of finalizers that are in our resources. Before was more complicated because you had both clusters that was reflecting resources one to the other, also in the peering phase resources. Now we designed it to have only the consumer cluster that pushes resources to the provider one. So you don't have provider resources that are in the consumer side. So from that perspective, is easier to clean up, to completely clean up the cluster. Francesco Torta and Francesco Cleinasso, correct me if I'm correct, but we didn't test explicitly the cleanup scenario if one of the cluster is completely missing. I think we are not currently testing it. But it's something that definitely is easier to do than before.
Yes,
Obviously, we
it's
can discuss to add some LiqoCTL command in order to make even easier this.
Yeah, but it's just a matter about how LiqoCTL work, not about how Liqo work. Nowadays, if you want, you can delete all the resources created on the consumer cluster. For example, if you follow the manual peering approach inside the documentation, you can find it in the advanced part in the documentation. You can revert the process and delete manually all the resources, and you can achieve this cleanup. It's not something really difficult to integrate inside the LiqoCTL. So thank you. We will think about integrate it in LiqoCTL.
Yeah, my question was in the spirit of the communities, this can be something that is useful in your opinion. I think maybe so. I think that something that, because all the if I seen rightly, all the resources for the peering are limited to the tenant namespace. So if we have to clean up something, maybe just cleaning the tenant namespace leave. I think it leave none or few resources to be deleted. Or more. Okay.
Yes, that is, but there are still finalizer on some of these resources though. So if something is completely break, you need something that understand it and removes these
Yeah.
these
Okay.
finalizer resources. Fulvio, I see that you have
So the short answer is there is no a single kill-all command with LiqoCTL, but if you make different commands, let's say manually disabling, offloading, and blah blah, you can achieve the same result, even if the other cluster exploded. Is it correct?
Correct.
yes.
Oh, another thing why we are in the on the argument, I have noticed that when you unpeer the two clusters, the namespaces created for the peering are remain in both cluster, and I think some resources remain inside this cluster. This is something that is by design, so is something that is wanted, or is something that is planned. It must be so for, I don't know, some like optimization if you peer again or something, or it's better that the namespace created by the peering and the resources inside has to go.
No, it's something that we decided to do in this way.
Okay.
Because basically for the modularity perspective, because when you disable one module, you don't want in all cases to disable also the other ones. So removing the namespace can be dangerous if you are using modules in separately one with each other. And I think one of the main reasons that we did it in this way, I don't know if Claudio are in the call, because Claudio is the one that developed this specific feature, is that we have a LiqoCTL command that creates a temporary user with very, very restricted permission in order to create in the tenant namespace a user with that creates a kubeconfig for this user to be shared with a remote remote user that can establish a new peering. So if the user creates a peering with this permission, okay, so the remote cluster with the permission creates a new peering and then remove it. If we remove the namespace, we also remove the permission that are related to this namespace. So it will result in a one-shot permission to do peerings. While
Yeah, makes
the main
sense.
reason, actually, the main reason is we don't want to remove something that we don't want. Yeah, we don't want to remove something unwanted. So if I have some resources in that namespace, deleting the namespace could be dangerous because we can remove something that we don't want to remove. That's the short answer. And in that case, for example, in the case of the peering user, we might remove the permissions for that user.
Yes, in any case, we have a flag in the liqoctl peer command that removes the namespaces after the successful unpeering. So if it's something that you want to do to remove these namespaces, we have an option to do this thing.
Okay, thank you. It's very you replied very thoroughly to my question. Thank you.
Thank you too.
Hey folks, it's Sean here from Bot Auto. So we are using Liqo to pair our EKS clusters to our on-premises cluster. And recently we are encountering a problem about the resource quota. So for example, we set the GPU quota on Colo, like for namespace A for 5 GPUs. And in total, we have 10 GPUs. So it's on the provider side, but on the consumer side, the consumer side is not even aware of this resource quota. So on the consumer side, I send like 10 requests, request 10 GPUs to the provider side. And all those requests will go through all the way to the provider side, and the provider side will do the throttling. But on the consumer side, it says, okay, I have 10 GPUs and I have 10 requests. So all the GPUs are kind of occupied. But in fact, on the provider side, since we have the resource quota, we only use 5 of the GPUs. So back to the consumer side, if I send another request to another namespace, like namespace B, all those requests are not able to go through Liqo to the provider side, because on consumer side, it says all 10 GPUs are occupied. So it's kind of, we'll still work on some kind of workaround, but it would be better for Liqo to deal with this kind of resource quota, to let the consumer side be aware of the resource quotas on each namespace is set up on the provider side. So I was wondering if there are any better solutions to deal with this situation.
Yeah, I don't know if someone else want to answer this, but the short answer on my side is that we don't have easy workaround for this. I think I'm not sure, 100% sure of what is happening, but I think that it can be due to the fact that the pod is not scalable in the provider cluster, not in the consumer one. So when the pod in the consumer cluster perspective, the pod is up and running in the virtual node, or at least is seeing that these resources are acquired by this pod. So the local Kubernetes scheduler is not scheduling other pods on this node. I think yeah.
Sorry, go ahead.
I think that one possible solution can be something that detects this scenario and deschedule the pod that are not schedulable in the remote cluster. We don't have something ready to do that. It's something that needs to be developed. But something that is detecting the fact that the pod is not runnable in the remote cluster, and in some way try the scheduling it, making this its resources available again for other pods in the consumer cluster. I don't know if other have further things to add to this.
I'm sorry, can you say that again? I didn't get your last few words.
What I was saying that probably the easiest things to do is to detect the scenario and evict the pod from the consumer side. So the consumer can evict the pod in the virtual node. The resources will be available again, and the Kubernetes scheduler should be able to reschedule the other pods that can be executed on this node.
Okay. Yeah, I will give it a try. Thank you.
So as I say, you is not an easy workaround on this, but
Is there an issue about this in the GitHub repository?
I don't think there have one, but I can create one to track this issue.
Thank you.
Okay, thank you.
Yeah, sure.
So that we can discuss about it in the issue.
Yep, we'll do that.
Thank you.
And maybe if useful, we can also put this in agenda in one of the upcoming meetings.
Yeah.
Yep, sounds good. So actually, for now, our solution is very rudimental, is to kind of use the, because we still use version 0.10.3. So we use the resource plugin to kind of overwrite the overall resources from the provider side. So we see we have 10,000 GPUs, and we just offloading all the tasks to the provider side, and let the provider side to choose whether to run them or let them pending, because the resource quota only works on the provider side. But I think that's just a temporary solutions. So we are expecting a more like formal support for the resource quota from Liqo. Yep.
Sandro, do you have a question?
Yes, I have a question about the code that I wrote. For example, or if someone wants to contribute in the Liqo developing, where should I eventually upload it to receive feedback, know if what I'm doing is right or wrong, or if I can do it in other ways? I don't know.
Something that probably we
If
can
it's
discuss
something
a
that
lot.
is okay.
Yeah, it's something that we still need to to side. I think that at the moment, if you want to create your own, I think you already have a GitHub repository. If you want to make it public and share it in the communities like Slack channel, I think that it can be something to start. In the meantime, we can provide you additional information on what to do. I don't know if the other maintainers have
I
better
don't have any.
ideas.
Yes, usually the approach is to open an issue on GitHub also, so that we discuss and eventually follow the right track straight away, just to avoid to open a PR with full of code that is not being discussed before. So we can anticipate eventual problem, and we are more aligned. So for sure, Slack community, like Alessandro said, and GitHub issue is the first thing to do.
Yes, Francesco, it's something, okay, this is 100% correct for something that needs to be merged inside Liqo. But this thing, as we are saying, is something that works on top of Liqo using the Liqo APIs in order to establish this direct connection. So I don't think that is something that will be in the core of Liqo in the short time. So probably a roadmap that can be interesting can be okay, a Santo repository. So that as the code, if it's something that that the community is using, is something that can be in Liqo community, Liqo sandbox or something like that. We need to define organization on GitHub is something that can have all the repositories that are not yet stable and core inside Liqo, but something that is in the way of being and is being evaluated from the community. I think we can discuss between maintainers this and have an answer. I think that can be something like that.
Yeah, agree.
Fulvio?
Yeah, we didn't discuss exactly this, but we need a way to measure the consensus of the community against a specific feature. Maybe one thing that we can do is measure through the comments and the approval means thumbs up or something like that on GitHub. So the number of people may be interested in that feature, maybe using that. I don't know what the other member of the community think about that.
And also if someone is using it in a testing environment or in general for every project that is related to Liqo, if the people in the community want to provide us the information about their usage of the tools, it can be useful to understand the most important things, the things that people are actually using, and how to improve the whole ecosystem.
Any other question? So we reached our 1 hour slot. If there are other questions, otherwise we can stop here and we can sync on the Slack channel for the next community meeting. And please be active in general so that we can interact and we can allow this project to grow, especially from the point of view of adoption, which means features that are not foreseeing by, let's say, the original group of maintainers, because we have our use cases, you have your, and so it's something that we have to put together. Any other questions?
I have a quick question.
Yeah.
Can you hear me? Okay. So, hello, I'm Pedro Ascensão from the University of Coimbra in Portugal. This is a fantastic tool, and it has helped me a lot through my masters, and I've been using it so that in a way to basically try to monitor different applications and try to offload different applications with the minimum offload latency possible for basically safe exit scenarios. So vehicle to infrastructure and vehicle to vehicle, in those types of scenarios, to try to help pedestrians and so on. But my issue here, and this is a very quick question, it's regarding the use of Prometheus with Liqo. Because I have already managed to use Liqo in different ways. And at least for me, so far, it's not I'm not quite sure how Prometheus should interact, in the sense that Liqo is expecting, for example, a separate server to run Prometheus. Is it supposed to, for example, all the clusters that are peered to have the flag enable metrics for all the clusters to expose their metrics? I would just, if someone could talk a little bit about how Liqo exposed those metrics to Prometheus, so that everything can be measured and monitored for these specific latency issues, to prevent latency issues, basically.
Basically, on Liqo, we expose metrics using service monitor and pod monitor. The custom resource is used by Kubernetes stack. So if you install Liqo enabling the metrics, automatically these resources are added inside your cluster. So if you already installed the Kubernetes stack, you can see the metrics by default. You don't have to do nothing. You don't have to expose a Prometheus from another cluster to another cluster. Every matrix is local to a cluster. So, for example, if you want to see the metrics about gateways, okay, about networking in connection between clusters, okay, you will have some metrics from a cluster and some metrics from another cluster, but you need to install Prometheus and Grafana on every cluster. Okay, you are not able to scrape metrics from another cluster. If I don't know if I answered
Yes.
Yeah.
Thank you for that. Yes, and so in this case, so Liqo is not it's not supposed only to work in a specific type of environment. I don't know if I'm managing to explain it well. So in this case, I was trying to just install locally the Kubernetes stack that you're mentioning for all the clusters. So Liqo, one of the lines in the documentation just said that it's already takes into account that there is a underlying service of Prometheus running. I just wanted to clarify if I can do just the Kubernetes stack on all the clusters, or it would also work with specialized server, external server to all of these ones, to monitor and try to scrape metrics.
Okay, what I suggest is to install Prometheus on every cluster.
Okay.
And then you can use a project like Mimir or Thanos to
Yes, exactly.
collect metrics from every cluster, and then you can have just a single instance of Grafana to
Because
show.
technically, if you have an external Prometheus server and manually add the endpoints of the Liqo pods, we
It
should
should
always
work.
expose the metrics, but obviously you don't have all the automations that are from the Prometheus Cube stack deployment, so you don't have the automation provided by the pod monitor, service monitor, etc., in order to automatically discover and collect metrics from these endpoints. So what I suggest you is to use the Prometheus operator in order to scrape the metrics on each cluster. You can use the Prometheus operator to configure a Prometheus agent with a remote write server mode, so you can have a central Prometheus to collect all the metrics and then configure the Prometheus in each cluster to not store locally the metrics, but to push them to a centralized one. That can also be in one of the clusters, and you can use Liqo in order to offload its services to the other clusters. But it's something that I suggest you is to use the Prometheus operator on each cluster.
Yeah, thank you. Yes, that's the goal to ultimately use Liqo. Yeah, so and try to even use another scheduler with Liqo, because there's already a paper on that from the Politecnico di Torino. So I'm basing on that. So thank you for your insights, and congratulations on the awesome tool. Thank you.
Thank you.
Thank you very much.
Thank you.
I think we should stop, because otherwise we don't have anything to do in the next community meeting. So thank you everybody for this very warm participation and all the questions and all the people who spoke here today. Thank you, and let's meet in the next meeting. We will let you know the next date as soon as possible. Thank you very much.
Thank you.
Thank you. Goodbye.
Bye.
Bye-bye.
Bye.
Thank you. Goodbye.
Bye-bye.